Now here we have to find the derivative of x cube minus 4 cos x plus log x into tan x. So to differentiate means to find the derivative. Now here we see that on high level we have some function minus another function plus some another function. So the derivative of this entire function will be nothing but derivative of first minus derivative of second plus derivative of the third function using the algebra of derivatives. Now let us denote this particular expression as, say, f of x. So f of x is equal to x cube minus 4 cos x plus log x tan x. Now we have to understand that in log x tan x is the product of log x and tan x. Okay? So therefore the derivative, which is f dash of x, is given by, if you observe the first function x cube, that is of the form x raised to n, right? And if we remember, the derivative of x raised to n is n into x raised to n minus 1, correct? So therefore derivative of x cube will be 3 into x raised to 3 minus 1, okay? Which is 2, but I have purposefully written since we are doing it for the first time, minus, now 4 is a constant, so it will remain as it is, and derivative of cos x is minus of sin x from the standard table. Okay? Now moving on, plus, now if you see, the last function is itself a product of two functions, that is u and v. Okay, so let's call log x as u and tan x as v. So using the product rule, the derivative of this product is first function, which is log x, into derivative of second function, that is derivative of tan x, which is sec square x. And this you can verify in the standard table, that is derivative of tan x is sec square x, plus we have to write the second function as it is, that is tan x, multiplied by the derivative of first function, that is derivative of log x, which is 1 by x, right? So that completes the evaluation. So now we have to just simplify this. Now first term is nothing but 3x square. Now second term effectively becomes positive, that is 4 sin x. Then next term is you have product of log x into sec square x, and the last term is plus tan x whole divided by x. So that is the final answer, which is in most simplified form, right? Let's see one more question. Differentiate y given by x square minus 1 whole upon sin x. So here we see that it is of the form u by v. So where we can call this numerator as u and the denominator as v. So we see that we have to use the division rule. Okay? Now if y is given by this, therefore the derivative, now here we represent it as dy by dx is equal to, now if you observe the formula, let us write the formula first so that it will be easy. The formula is v into du by dx minus u into dv by dx whole upon v square. That's the formula. So therefore, now v is nothing but the denominator function, that is sin x, multiplied by derivative of u, that is derivative of numerator. Now in the numerator we have first term as x square, so its derivative is 2x as we have seen previously, minus derivative of 1. Now as 1 is a constant, so therefore its derivative will be nothing but 0. Alright. Next we have minus sign, then u is nothing but the numerator function, which is x square minus 1 into derivative of denominator. Now derivative of sin x, we know that it is cos x. So that's what we write here, whole divided by v square, that is derivative of denominator square. Sorry, that is the square of the denominator, so that is sin square x. So therefore we'll just simplify this. The first term is nothing but, you can write it as say 2x sin x minus x square minus 1 into cos x whole divided by sin square x. That's it. So if we want, we can simplify that further also, but it's not that mandatory. So cancelling sin x from the first portion, we get 2x whole upon sin x minus x square minus 1 into cos x whole divided by sin square x. Right? So that is the required derivative.